All right, let's talk about something that is literally all around us, but completely invisible. It's a piece of tech that keeps our digital world from just grinding to a halt. It's called OFDMA, and honestly, it's the unsung hero powering our hyper-connected lives. So, let's dive in.
Have you ever been in a massive crowd? You know, like at a concert or a big game, and you just wonder, how on earth is my phone still working? How can tens of thousands of people all be sending photos and streaming video at the exact same time, without the whole network just collapsing?
Well, the answer isn't magic. It's an incredibly smart piece of engineering called OFDMA. This is the technology that manages all that digital chaos, making sure every single device gets the little slice of the internet it needs.
So, how does it pull this off? Well, it all comes down to a really revolutionary way of sharing the airwaves. And to get why it's so different, we gotta look at how things used to be done.
Think of the old systems kind of like a single-lane highway. One car, or one user, gets the whole road, and everybody else just has to sit there and wait their turn. It's incredibly inefficient. The OFDMA way? Totally different. It's like turning that one lane into a massive superhighway with hundreds of tiny, super efficient lanes that everyone can use at the same time.
Yeah, I know, that's a mouthful. Orthogonal frequency division multiple access. But let's just break it down real quick. Frequency division just means it divides the wireless channel. Multiple access means it can serve a whole bunch of users at once. And that first word, orthogonal, well, that's the secret sauce. That's what makes it all work so beautifully.
To really, truly get this, let's forget about radio waves for a minute. We're gonna talk about something way more fun. Yep. Let's imagine your entire wireless connection is just one giant, delicious pizza. This little analogy is actually a perfect way to picture what's happening behind the scenes.
So, in our analogy, the whole pizza represents the total available bandwidth. It's the entire resource that needs to get divided up among all the hungry users who are connected to the network.
Now here's where it gets really clever. OFDMA doesn't just cut the pizza into, say, 8 big slices. No, it carves it up into hundreds, sometimes even thousands, of tiny bite-sized slices. And each one of those is what we call a subcarrier.
And this system is incredibly smart about managing this whole pizza party. Everybody gets to eat at once, but the network gives out resources based on what you need. Are you streaming a 4K movie? Okay, you get a whole bunch of slices. Just sending a quick text, you only need a couple. And the most important part is, nobody's slices get mixed up with anyone else's.
Okay, so we know how it slices the pizza, but why is this method such a complete game changer? It turns out slicing up the bandwidth this way leads to some massive real-world advantages.
Remember that complicated word from a minute ago, orthogonality? This is the secret ingredient that makes the entire recipe work. It's the technical magic that's happening behind the curtain.
So what does it really mean for these signals to be orthogonal? It sounds super complex, but the idea is surprisingly simple if we just stick with our pizza analogy.
In simple terms, it means all those little subcarriers, those tiny slices, are mathematically designed so they don't mess with each other at all. Think of it this way. The radio waves for each slice are packed so incredibly close that they actually overlap, but the peak of one wave lines up perfectly with the 0 point of all the others. It's this neat mathematical trick that means they don't interfere, letting us pack the airways with just incredible density and efficiency.
And all that efficiency translates directly into stuff you actually notice. We get those high data rates for streaming and that super low latency or lag that you need for smooth gaming and video calls. It also means the signal is way more robust, especially when it's bouncing off buildings in a city.
And just to give you a sense of the scale we're talking about here, we're not talking about 8 or 12 slices of pizza. A single, standard 4G channel can be divided into roughly 1,333 of these individual subcarriers. That is an absolutely incredible level of precision. It lets the network manage data with, surgical accuracy.
So, the final and maybe most important point is that this isn't some weird futuristic tech. It's in your house, it's in your car, and it's in your pocket right this second.
Seriously, every time you use your phone on a 4G or 5G network, you are using OFDMA. If you've got a newer router at home, one that says Wi-Fi 6 on it, that's using OFDMA to juggle all your smart devices, your laptops, and your phones without ever slowing down. It is the absolute backbone of modern wireless communication.
And really, when you boil it all down, it comes back to this one simple, powerful idea: serving a lot of users, all at the same time, with really high efficiency. That's the core mission of OFDMA. So the next time you're in a super crowded place and your phone just works, you can thank the elegant pizza slicing logic of OFDMA. It kind of makes you wonder, though, as our world demands more and more data faster and faster, what other resources we going to have to learn how to slice up this efficiently?